Let's review again what we have learned yesterday, and I'm going to show you this video. So let's say we have y equal to cos theta. The high point is 0.1, inflection point 90,0, low point 180, -1, inflection point 270,0, and 360,1 as the high point. So this is full of one full period of y equal to cos theta. Let's say we have the transform functions, which is the blue graph over here. So let me change this a bit. We have c plus a cos b theta minus d. As we know that c is talking about the vertical translation. Yeah. So if I switch something to c, what will happen? I'm going to show you later. Okay. So b is the related to the period, but is not period. D is the pace displacement. Yeah. Okay, and A is amplitude. Okay, so C, let's say we have C and we change this, change the value. So you can see that the sinusoidal axis move along with the with C. Okay, yeah. So we can try to adjust that, and let's put 0 again. And let's see what happens if we have A, which is the amplitude, right? Now we can set the value. Let me change the value into 4, and let's see what happens. You can see that when you have 0,1 and it's transformed into 0,4, it means dilated, and then 90,0 is still same. 180, -1 becomes 180, -4. It means that it's dilated in a vertical directions by 4 units, by a scale factor of 4. Let's get it back to 1 so we can see what happened when we get B. Let me change the value of B a bit. Let's put it 0.1. Okay, and let's see if we change the value from 0.1 to 2. It has a horizontal dilations, right? It means that it's changing the period. Yeah, let's put it 0.5 and let's see what happened. 0.1 still 0.1, and then 90,0 become 180,0. So it becomes enlarged by 2 times. Yeah, and then 180, -1 becomes 360, -1. That's what happened. And if I change this into 1.5, okay, actually it becomes shrunken or becomes smaller instead. Yeah, we have 90,0 becomes 60,0 since we times it with 1 over 1.5, and then 180, -1 becomes 120, -1. And let's see. Let's put it back B into 1 so we can change the value of D. Yeah. And if we change the value of D, you have the horizontal translations. I set the value from -180 to 180. So let's change the value bit by bit, and let's put it 90. Okay. Now if we put it 90, as you can see that it changed the value, it shifted 90 degree to the right. Yeah, so 0,1 become 90,1, and 90,0 become 180,0. Yeah, let's put it 60, okay, instead of 90 because it's kind of fake for us. 0,1 becomes 60,1, 90 become 150 added with 60, and then 180 added, it becomes 240, -1. Okay, so that's what happened. And let's change all of this value together, and let's see what happens. So C, let's begin with C. C, let me put it to 2. Okay, I'll change it into 2. Kind of slow, yeah. Okay, and then A, I'll change it to, what is the best number? 1.5. Okay, and then B, I'll put it 0.5. Okay, then this is what the graphic will look like. Okay, so if I put it again, 2, it means that sinusoidal axis over here, yeah, and then 1.5, it refers to the distance from the sinusoidal axis to the high point, or from the sinusoidal axis to the low point. So I'll have it this way, 1.5, and then over here 1.5. Yeah, the amplitude. Amplitude. And if we have 0.5, it means that from 360 degree, as you can see, this 360 degree, it get dilated by scale factor of 2. So instead of 360 degree, then it becomes 720 degrees. So you can see that the period becomes so wide. This is 720 degree. That is the period. And then negative 60 degree over here, it means that it has a phase displacement for cosine. So you'll have it over here. This is 60 degree. This is the phase displacement. Okay, so this is the review of what we are having yesterday. Let me throw one more questions, and let's say we are told to find the equations for this graph. Okay, so if we are told to find it, then there are several points that we need to do. The first thing is to draw it again, because this is just half of the period. Okay, so I'll add one more. Sometimes when the students add the other half, they put it this way. Okay, this is not the sinusoid functions. Okay, you should put it this way. Yeah, okay, because you have that this is concave up, and then you'll have a concave down, and you'll get the this one. Or you can also add it over here. This is better. I'll prefer the second one, so I'll erase this. Okay, and let's put some information. The sinusoidal axis, I think it's quite easy if we already draw it. This will be 7. The amplitude will be the sinusoidal axis to the distance from sinusoidal axis to the low point or to the high point. In this case, that will be 3. Okay, and then the period we can take a look from here. This is the half of the period, which is 40 degree. So one full period is 2 times with 40 degree, which is 80 degree. Yeah, so it's stop over here. And what is the coordinate? If this is 40 degree, then we'll get that this is also 40 degree. So just subtract 80 degree with 40 degree, we get 40 degree. And what is the phase displacement? Okay, so the phase displacement, I think I'm going to use sine for this case, because it's easier. It has an inflection point and it has the shape of sine. So it begins at 40 degree. Yeah, so I'll have, this is the phase displacement is 40 degrees. So I'll put it back, y equal with c plus with a cos b, and not cos, sorry, sine b theta minus with d, and we'll have c is 7 plus with 3 sine of b. What is b? So b is equal to 360 degree divided by 80 degree. Cross the 0, 36, 8, we'll get 9 over 2, which is 4.5. Okay, or I'll just put it 9 over 2, and then theta minus with 60 degree. 60 degree, 40 degree. Yeah, so that's how we can make the functions. Today's lesson will be quite short because we are going to graph tangent, cotangent, secant, and cosecant. So we are going to begin from what we already know, which is sine and cosine functions. I'll present it like this. So the blue graph over here is the y equal with cos theta, because it begins from the high point and then go to the high point again at 360. So I'll put it y equal with cos theta. And then the red graph is y equal with sine theta. So I'll put it y equal with sine theta. Now we know that tangent theta is equal with sine theta over cos theta, right? So it means that the value of sine divided by this value of cos. So if we have, let's say over here, when you get the sine is 0 and the cosine is 1, okay, then this will be 0 divided by 1, the red graph divided by the blue graph value. So you'll have 0. When you have over here, what is this? 45 degree. 45 degree, 1 divided by 1. So you'll get it over here. Yeah, 1 divided by 1. And then what happens when you have the sine value is 1 while the cosine value is 0? So you'll have 1 divided by 0, and that will lead to infinity. So you'll have something like this, goes up so high, okay, and then this will be the vertical asymptote, VA, I'll put it. And same thing when you try to plot it over here, okay, wait, when you try to plot it over here, you'll have it becomes negative, so negative when it approaches negative 90, when it approaches negative 90. Okay, so you have two vertical asymptotes. Actually, it's not only two, you have several vertical asymptotes, which I'm going to draw it over here. Yeah, and it repeats again. If I ask you what is the period, then again, the period means that the functions will come back to its value at that time. Okay, as you can see, that this one is a 1 full cycle for tangent, so from negative 90 to 90. So the period for tangent is not 360 but 180 degree. This is for tangent. Yeah, 1 full period of tangent theta is 180 degree. I'll show you what the graph look like. So this is what it looks like. Yeah. Let's have cotangent. In order to graph cotangent, I will need the graph of tangent. So because I know that cotangent is the reciprocal of tangent, right? So if I have, like over here, I have the value of tangent is 0, then I will have a 1 over 0 for cotangent. It means that on this part there will be a vertical asymptote for cotangent, and also over here, yeah, there will be a vertical asymptote. Why? Again, because you have the value of tangent is 0, so cotangent is 1 over 0. 1 over 0 will be undefined, and it will create the vertical asymptote. Also over here, yeah, so we have it like this. And when it comes to undefined over here, so like 1 divided by undefined, then it will comes to 0. So you'll have over here, this is 0, and then this is also 0. Yeah, so I'll try to approach it like this. Okay, and then this one also. This is how we graph it. Okay, and over here we'll have 0 also, so probably from here. Wait. Yeah, okay. I'll show you a better graph. Okay, so this is y equal with cotangent theta. Okay, then let's move to secant. Yeah, okay, to have secant, I will need the secant is the reciprocal of cosecant. Sorry, so I'll have cosine functions like this. Okay, so this is a cosine function. Okay, when we have a cosine functions, we can get the secant functions by doing what? By doing the reciprocal of it. So take a look. When you have 1 over 1, then 1 over 1 is equal to 1. Okay, I'll put it in red, 1. And then when you have 1 over 0, that will be undefined. So you'll have every time the cosine reach 0 value, that will be a vertical asymptote. So I'll have it over here. This is the vertical asymptote, as well as over here. Again, because you have when 90 degree you get 0 for cosine, and that will create a vertical asymptote for secant. Okay, so that's the vertical asymptote. And when you have negative 1, okay, over here negative 1 divided by 1, then you'll get negative 1 also. So when you try to approach it, it will be something like this. One part goes like that, okay, and then the other part is this, and then goes back again to this part. Yeah, okay, a bit bumpy over here. Okay, I'll show you a better graph. This is y equal with secant theta, which is the reciprocal of 1 over cos theta. Okay, let's see the last one, which is cosecant. Yeah, so if we are told to find cosecant, so same thing since cosecant theta is the reciprocal of sine theta, then when sine theta equal to 0, the cosecant theta will have a vertical asymptote, and it happens at 180, 0, and 360. That this is the vertical asymptote. When it comes to 1 value, then 1 divided by 1 is 1. So I'll have this kind of graphic. And then when I have negative 1, then it becomes something like this. Okay, what is the better graph? Wait. Okay, so this is the better graph. Again, tangent will have a period of 180 degree. Cotangent is 180 degree also. Secant will be 360 degree, and then cosecant will be 360 degree also. As you can see over here, for cosecant, you have like a 2 curve like this, yeah, which is different, and then it repeats again. Okay, so that's for today.